Okay, now the derivation of conical pendulum. So again, this is a diagram of conical pendulum, so which is having a bob point mass m and string of length L. So AB is the length of the string, which is L, and BC is the radius. Okay, now at this position B, the forces acting on the B are weight mg vertically downwards and force due to tension, which is T naught. Then again T naught is divided into two: T naught cos theta vertically upwards, which balances the force mg, weight mg, and T naught sin theta, which is horizontally, so it will balance the centripetal force. So the derivation will come here: T naught cos theta is equals to mg, and T naught sin theta is equals to mr omega square. So when you divide these two, T naught sin theta upon T naught cos theta is equals to mr omega square upon mg. So m will get cancelled, T naught will get cancelled, and you want omega, right? So omega square is equals to this, g will go there, g sin theta upon r cos theta. Okay, now if you see this figure in triangle ABC, if you want sin theta, which is opposite upon hypotenuse, okay, opposite of theta is BC and hypotenuse is AB. So BC is R and AB is L. So you got R as L sin theta. So you are going to substitute the value of R here. So first we want T. Now capital T is the period of revolution and T naught was at force due to tension. So clarify these differences. Now omega is equals to 2 pi by T. Okay, this is the formula. Now you are going to substitute the value of omega here. So omega is equals to root g sin theta upon r cos theta is equals to 2 pi by T. Okay, so g sin theta, r, you will going to substitute this value L sin theta cos theta. So sin theta gets cancelled. So if you want T, T will go there, this all will go there. So T is equals to 2 pi root L cos theta will go upward and G will go downward. Now this was the period T. If you are asked about the frequency, then frequency is denoted by small n, which is 1 upon T. So when you reciprocate this, you will get 1 upon 2 pi root G upon L cos theta. Since this L and G are constant, so both T and N depends on theta. Okay, and frequency is independent of the mass of bob. This means, see, in the frequency there is no m here. That means this is independent of the mass of the bob. The question can come as this: to show that the frequency of a conical pendulum is independent of the mass of the bob. So with this relation you can prove this. Okay, next derivation is vertical circular motion. Okay, so this is the diagram. Consider a bob tied to an inextensible and flexible string whirled along the vertical circle, so that the bob performs a vertical circular motion and the string rotates in a vertical plane. Okay, this is a simple diagram which you can draw. Now let's start the derivation. At the uppermost position A, both weight mg and the force due to tension, see, both are in downward direction. Okay, so, and both are moving towards the center. So you are going to add this: Ta plus mg is equals to mv square upon r, which is the centripetal force. Okay, now if you want the minimum possible speed at this point A, so Ta is equals to 0. You substitute the 0 here. Mg is plus 0 is equals to mva square upon r. That is mg is equals to mva square upon r. Gets cancelled. And if you want the speed, then va is equals to rg. If you take out the root, the va minimum is root rg. Okay. Now next, at lowest position B, the force due to tension and the weight mg are in opposite direction. This is going upward, this is going downward. So you are going to subtract this. Tb minus mg is equals to mvb square upon r. Now if you come from uppermost to downward, from here to here the distance is r and here to here the distance is r. So the total displacement from A to B will be 2r. Okay, and the motion is under gravity. So the decrease in potential energy, gravitational potential energy, is converted into kinetic energy. So the potential energy is mgh, which is converted into kinetic energy. So we just spoke that it is from A to B. So the kinetic energy will be half mvb square minus half mva square. Mg and the displacement is 2r, so h will be 2r, half m will be common, so vb square minus va square, gets cancelled, this 2 will go there to 4rg, so vb square minus va square is equals to 4rg. Okay, also if you want vb square, just like we got the speed at position A, we want the speed at position B also. So you are going to shift there, and this from 1 you got rg, so this is 5rg, root the vb minimum is equals to root 5rg. Okay, so you got va minimum and vb minimum. Now next what are you going to do? You are going to subtract equation 2 from 3. So tb minus mg minus mg plus ta. So and this was the left hand side, so you are going to subtract the right hand side of the equation as well also. So this will be this. So tb minus mg, the bracket will open, minus mg minus ta, m upon r is common, so vb square minus va square, this minus 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 2mg, vb square minus va square you got at equation 4 as 4rg. So this will go here, it will be addition, then tb minus ta is equals to 6 mg. You got the difference between both the tension as 6 mg. Now for the position at horizontally, that is C and D, it is same. You are going to similar mathematics, but you don't need to show the whole calculation, so you can write the similar this, and that's done of the derivation.